Hello students. In the previous lectures, I showed you how to solve linear programming problem using graphical method. I showed you two types of linear programming problems and their solution using graphical method, that were maximization of objective function subjected to two constraint equations and minimization of objective function subjected to two constraint equations. In this lecture, I will be solving the third type of linear programming problem using graphical method, that is maximization of objective function subjected to three constraint equations. So yes, this is the question that I'll be solving in this lecture. So this linear programming problem has the maximization. It tells to maximize the objective function that is equal to 100x1 plus 60x2 and is subjected to three inequality constraint equations, that is 5x1 plus 10x2 less than or equal to 50, 8x1 plus 2x2 greater than or equal to 16, and 3x1 minus 2x2 greater than or equal to 6. So as we used the technique for solving previous problems, the technique was to convert the inequality constraint equation into the equation form, and from that equation finding the set of points for x1 and x2, using those set of points to plot the line on the graph paper, and the same procedure was followed for all the constraint equations. We got set of lines on the graph paper, and then we used to shade the feasible region. We used to find the corner points of that feasible shaded region, and using those corner points we used to either maximize or minimize the objective function. So the same technique that we used for solving the previous questions, the same technique is going to be applied here. So I'll take the first constraint equation, that is 5x1 plus 10x2 less than or equal to 50, and will convert it into the equation form. So it is 5x1 plus 10x2 is equal to 50. I have marked it as equation 1. Now I have to find the set of points for x1 and x2. So first I will put x1 is equal to 0 and in the equation, and for that I'll find x2, and the second thing that I will be doing is putting x2 is equal to 0 in the equation and finding the value of x1. So when I will put x1 is equal to 0 in the equation, and after solving the equation I'll get x2 is equal to 5, and the next time when I'll put x2 is equal to 0 in the equation number 1, and after solving the equation I'll get x1 is equal to 10. So for the equation number 1, I got two set of points for x1 and x2. That is, for x1 is equal to 0, x2 is equal to 5, and for x1 is equal to 10, I got x2 is equal to 0. Next step, I will be plotting these points on the graph, where here the x-axis is representing the x1 decision variable and y-axis is representing the x2 decision variable. So plotting the points 0, 5, that is x1 is equal to 0 and x2 is equal to 5, and x1 is equal to 10 and x2 is equal to 0 on the graph paper, and joining those points I will get the line for that equation number 1. So this, for first constraint, inequality constraint equation, I got the line. Now next step that I will be following is I will do the same thing for the rest of the constraint equations, that is converting them into the equation form and plotting the line. So the second constraint equation that I will be taking is 8x1 plus 2x2 greater than or equal to 16. and converting it into the equation form, I'll get 8x1 plus 2x2 is equal to 16. Now same technique, put x1 is equal to 0 and find the value of x2, and x2 is equal to 0 and find the value of x1. You'll get two set of points. So after putting x1 is equal to 0 in this equation, 8x1 plus 2x2 is equal to 16, I got, after solving the equation, I got x2 is equal to 8. Similarly, when I put x2 is equal to 0 in the equation, and after solving the equation, I got x1 is equal to 2. So the two sets of points are x1 is equal to 0, x2 is equal to 8, and for x1 is equal to 2, I got x2 is equal to 0. Now plotting these points on the graph paper and drawing the line for this equation, I'll get the equation, the line in this form on the graph paper. I have plotted the points 0, 8 and 2, 0 on the graph paper, and I got the second line for the second constraint equation after joining the points. The next step that I'll be doing is, for the third inequality constant equation, I will convert that third inequality constant equation into the equation form, that is 3x1 minus 2x2 is greater than or equal to 6. After converting this inequality constant equation into the equation form, I got 3x1 minus 2x2 is equal to 6, and I have represented it by equation number 3. Now same thing, I'll put x1 is equal to 0 in the equation, and after solving the equation, I got x2 is equal to minus 3, and next I'll put x2 is equal to 0 in the equation, and after solving the equation, I got x1 is equal to 2. So the two sets of points are x1 is equal to 0 and x2 is equal to minus 3, and the next set of point is x1 is equal to 2, x2 is equal to 0. So plotting these points on the graph and joining the line, I'll get the line for the equation number 3. So here I have plotted the points minus 3, 0 and 2, 0, and after drawing the line, I got the graph in this way. Now next step is, I have to find the feasible region. For finding the feasible region, first of all, in this graph paper, I have got the lines for the converted equation forms. Now I have to shade the area as per the inequality constraint. And for that, I have to go back to the inequality constants and have to see whether the inequality constant is greater than or less than. So considering the first inequality constraint, that is 5x1 plus 10x2 less than or equal to 50 as given in the question, I found that it is less than sign, means the line that I've got from the equation 5x1 plus 10x2 is equal to 50, the shaded area will be less than the line, that is below the line. In a similar way, 8x1 plus 2x2 greater than or equal to 16 represents the shaded area will be above the line as greater than sign is there. And in the same way, 3x1 minus 2x2 greater than or equal to 6, again the shaded area will be above the line, having the equation 3x1 minus 2x2 is equal to 6, because here the greater than sign is there. Now if you are finding, if you're getting confused regarding this inequality signs and shading the area, then simple technique that you can apply is, put x1 and x2 is equal to 0, 0 in the constant equation, find the value and see whether it is satisfying the inequality constant equation or not. If it is satisfying, means the shaded area will have 0, 0 points, that is x1 is equal to 0 and x2 is equal to 0 points, means that area will be shaded. Otherwise, shade the opposite one. For example, 5x1 plus 10x2, taking the first constant equation, inequality constant equation, that is 5x1 plus 10x2 less than or equal to 50. Now put x1 is equal to 0 and x2 is equal to 0 in the equation. You will get 5 into 0 plus 10 into 0, which is equal to 0. Now obviously 0 is less than or equal to 50 means the inequality constant equation is getting satisfied, means the shaded area will be below the line covering the point 0 0. X1 is equal to 0 and x2 is equal to 0. So in this way we'll shade the regions. Next step is to find the overlapping of all the shaded regions. So here I have not shown you the initial shaded regions of all the 3 points. I have just shown you in this slide the overlapping shaded area. Overlapping shaded area. So the overlapping shaded area is shown here with the lines, shaded lines. Now next step is I need to find the corner points. The next step is I need to find the corner points of this shaded area. So the first corner point, and I have marked this corner points using A, B and C. The extreme corner points of this shaded area I have marked it as A, B and C. Next step is I have to find the points A, B and C. A, as it can be seen from the graph, that it is equal to 2. 0 means x1 is equal to 2 and x2 is equal to 0. Point B is 10, 0 means x1 is equal to 10 and x2 is equal to 0. Now I have to find the point C. Either if you have drawn very carefully on the graph paper, you can deduce it from the graph only, but if you are confused regarding the point, you can simply solve the equations. Which equations? See, the C is the intersection. C is located at the intersection point. At the intersection of two lines, that is line number 3 and line number 1. So take the equation of line number 1, that is 5x1 plus 10x2 is equal to 50, and take the equation of line number 3, that is 3x1 minus 2x2 is equal to 6. Solve the equation simultaneously and you will get to know the point C. So point C has come out to be 4, 3 means x1 is equal to 4 and x2 is equal to 3. Next step is I'll take the objective function, that is 100x1 plus 60x2 as given in the question, and I will be putting all the 3 corner points A, B, C in the objective function. Means since the A is representing the point 2, 0, that is x1 is equal to 2 and x2 is equal to 0. So I will be putting these points in the objective function 100x1 plus 60x2, and after solving I'll get objective function to be equal to 200. Similarly for rest of the corner points, I will be putting the values x1 and x2 in the objective function and find the value. So for point B, after putting x1 is equal to 10 and x2 is equal to 0 in the objective function, I got the value of objective function to be equal to 1000. Similarly for the corner point C, which is representing x1 is equal to 4 and x2 is equal to 3 in the objective function, and substituting these points in the objective function, I got the value of objective function to be equal to 580. Now after finding all the values of the objective function for all the corner points, I have to verify which value of the objective function is maximum. Since the question is maximize the objective function, I have to find the maximum objective function. So among these 3 points, among these 3 values of the objective function, I have found that for point B, the objective function is maximum, that is 1000. So the answer is objective function, the value of maximum objective function is 1000, and for that the value of decision variables that I have obtained after solving are x1 is equal to 10 and x2 is equal to 0. So these three types of linear programming problems I have showed you how to solve using the graphical method. So here I am ending the class. We'll continue further in the next class.